This is the Getting Started video for homework number 11. Now this is a continuation of the previous homework, so make sure you've got that functionized version or procedurized version and then just add on to it. Now the first step you got to do is you're going to write a procedure that will add a value to the end of the array, and I've given you the prototype for that. So add value to end of array, and it takes a pointer to a pointer. Why? Because we will be changing the pointer itself and a pointer to the size. Why do we need a pointer? Because we are going to change the size. We're going to increment it by 1 in the value that we're going to add. Now do not overwrite or replace the value at the end. Add a new element to the end of the array. So for example, if the array before the call to add value to end has 4 elements that are 2, 4, 6, 8, and we call that with the address of our pointer, array pointer, and the address of our size, and we hard code the value that we're adding as 10. After the call, our array should be 2, 4, 6, 8, 10. So essentially we're resizing it, and then we are putting a 0 on the end, or a 10 on the end. Then we can do the same thing with add value to the front. So for example, if the array before was 2, 4, 6, 8, and then we call that with add value to the front, then when we're done, or afterwards, we should get 10, 2, 4, 6, 8. Wow, that should be really challenging. Then we're going to have insert at, which is essentially the same thing except it goes somewhere in the middle. So if we call insert at with 2, 4, 6, 8, and then we call insert at with our pointers, and then we are going to insert the value 5 at location 2. After our call to insert at, we should have 2, 4, 5, 6, 8. Haha, pretty cool. And then finally, with our remove at, copy and paste that in there. If we call remove at with location 2 to remove, if I called that with spot 2 after, if we had 2, 4, 5, 6, 8 afterwards, when we are all done, we'd have 2, 4, 6, 8. It would remove the second element, all base 0. So that is an overview of what we're going to be doing. I bet you guys would like to see an example of how to do the first one. I've switched to Visual Studio. We've got all the code from the last one. Right after calculate array average, so this is the part 2 stuff. I'm going to put a comment in that. Part 2. And part number 1. I've got add value to end, and I just copied that prototype right out of the homework. And so we come right here before delete array, and so here's all the code, and I'm just going to copy that and use that as an example. Now we have to outline the steps that we're going to want to do. So we need to plan this out. So we need to add a value to the end of the array. Now this is extremely challenging. Why? Well, because we need a brand new hunk of memory of size 1 bigger. So allocate block of memory size plus 1. Then we need to copy all the values from the old array into the new array. And we need an add or set the last array element value. Then we need to delete the old array, and finally we need to assign pointer to new array to variable passed in. Oh my gosh. Now this is all the equivalent of redim preserve a int values and then whatever size, so size +1 if we were doing VB. So in VB you can say redimension an array, preserve the existing values, and make it the old size, or I think it's called length, +1. So make it 1 bigger. We're now going to find out how extremely challenging it is to do that. Okay, so the first thing we need is to allocate a new block of memory, and for that we need a pointer. So pa int new values equals 0. So we've got our pointer, and we are going to come up here and copy our code right there. So create array dynamically. How to do that? So pa int new values is equal to malloc size of, and then our array size. Now why is it mad about that? No, it's, oh, I got my semicolon. Gotta love that. There we go. So that's going to make the old size, but we add +1 to that for our new value. And remember, we have to multiply by the size of an integer and then cast that to an integer pointer. And then I need to copy all the values from the old array into the new. So let's do that brute force. And now you're going to find out why people love to use the bracket syntax. So let me do the brute force example first. What they do is they say spot 0 equals spot 0. And then you do 1, 2, 3, and so on. 1, 2, 3, all the way up until however many that you need. So obviously once you see it in that format, what can we use instead? We can use a loop. And since we know the start, stop, and step, we can use a for loop. And we are going to copy up until the old array size. And then we put one of those lines in the middle, and we replace the hard-coded value with our int index, and voila, we have copied all the old values. But we don't want to use the bracket syntax because the brackets are when you have an array. We do not have arrays. We have pointers to arrays. So what should we do instead? Well, we should use the pointer arithmetic syntax, which really isn't that bad. There we go. So first we dereference to get the pointer to the array. So that's our base pointer. Then we add our offset to that, and then we dereference a second time to get the contents at that address. And this is where our prefixes really save us. Did you know that there are some people that say that actually hurts readability, and instead you should use something like V and O or N, so that would be the new array. And so then you get this code. Wow. Yeah, of course then you'd use I. Yeah, right. That really hurts my eyes. So here's the brute force with the bracket syntax. Here is the loopized version of that. And then here is the loopized version using the pointer arithmetic syntax. So we'll go ahead and delete that. Are you ready? And so we copy all the old values, the values from the old array into the new one. And we didn't get the last spot, so let's go ahead and do that last spot. Now some of you might be tempted to terminate it. We're dealing not with strings but with numbers, so no, there's no termination here. What value goes in that last spot? Well, it is the value to add. So that's how we do that. Now that old array is no good anymore. It has one too few elements in it. So what we're going to do is we are going to free that old memory. And we have to dereference once to get to that block of memory. So it is gone. And if you are cautious, like I am with good reason, you will set that pointer to 0. We are done using it. We can't access that memory anymore. Next, we need to assign to that pointer the new array, which is this guy right here. So we've done a switcheroo. Now, what I like to think of is kind of like leashes to a dog. So here we've just gotten a whole bunch of leashes to a dog. And we copy the dogs over one at a time into the collars. Then we add a new dog at the end. And here we give back all the dogs and the leashes to their old owners. And then here I hand off the leashes to another handler. So they're both holding on to it. Now, you do not want to free PAint new values because both of these pointers point to the same thing. If you free, then that is the same as freeing this. That's pointing, and we lose all that memory. So that is not what we want to do. We do not need to free it there. Alright, now one last thing to do. Our array size has changed. So the contents at that address, it is now 1 larger. Oh my gosh. Wow. Oh, that is really pretty amazing. And that is how you resize an array by 1 element. But we're not done yet. We haven't tested it. So we go up to main, and right after calculate average, we are going to call add value to end, and we're going to pass in the address, PAint values. Why the address? Because we are going to change the pointer itself. We're going to pass the address of our array size. Why are we passing the address? Because we're going to change it. We're going to make it size 1 larger, and I'm going to add 10 to the end. Then afterwards, to make sure it works, I'm going to go ahead and print it. Use a little comment block. Go ahead and run that. Size 4, 2, 4, 6, 8. Boom! Look what I did. I cast a 3rd level magic user spell, Corrupt Heap. And so I definitely corrupted the heap. Let's go ahead and comment that out and rerun it. So size 4, 2, 4, 6, 8, and it still works. So you know what that tells us? It tells us that our bug is in there, which means we got to step through it with the debugger. Let's go ahead and run that. 4, 2, 4, 6, 8 stops that line there. We will step into the code. So we allocated a new hunk of RAM, and size 4, so 1, 2, 3, 4. The new values, the index, we're going to go ahead and add that value. So if we look at the array, it seems to be happy. We are going to free the old values, set it equal to, we set it, plus equal to 1. Not real sure what's going on. So what do we do? How do we fix that? Well, we divide and conquer. Oh, I'm going to show you guys a cool trick. You are going to love this. So I saw this from a student. You know how you can expand and collapse these areas? Well, you can make your own areas with the pound pragma region command, and then you can, for example, call this part 1. This is the all part 1 stuff. And then you gotta put an end to that. So find array, calculate. Here we go. So pound pragma end, or region end. Is that it? Wait a minute. What's the? Hold on. Let me pause and come back for that. Okay, so it's pound pragma end region. Now, what did that do? I'll come back up here to part 1, and I can collapse it. Isn't that neat? So that makes it easier for me to debug, because I can see the call right here in main, and then the code for it is immediately below. And so that is pound pragma region, and then you can give it a title, whatever it is you want, and then pound pragma end region, all one word. And that is how you, and you put something in between that, and that's how you expand and contract. Isn't that neat? Oh. So Kevin showed me that one. Appreciate that very much. So that should make debugging easier. Now, how am I going to fix this? Well, I'm going to temporarily comment out some of this stuff. So I'll comment out all that. All I'm doing is allocating the memory. Now, go ahead and run it. 4, 2, 4, 6, 8. And I'm going to go ahead and I'm going to get rid of my breakpoint. Just going to go ahead and run it. And it liked it. So what does that tell me? This block of code worked fine. Let's go ahead and uncomment the next piece. Go ahead and rerun it and see if my error lies in there. So size 4, 2, 4, 6, 8. That worked correctly. So I know the problem isn't there. So let us uncomment this bit. Go ahead and run it. 4, 2, 4, 6, 8. Oh, that worked. Woohoo! Okay, so now we uncomment this and see if that is the problem. Uh-oh. The rest of the program is going to blow up after that if we try to delete something. Oh no, we set it to 0, so that'll be fine. Go ahead and run it. 4, 2, 4, 6, 8. We can't print afterwards because it's unallocated. So right here, this print, I'm gonna have to comment that out. 4, 2, 4, 6, 8. That worked. What's going on? That's crazy. Okay, well, maybe it's this bit. Let's uncomment that. So we say that the old pointer is equal to the new pointer, and then that the contents at is equal to plus equal to 1. Okay. Go ahead and run it. 4, 2, 4, 6, 8. Heap corruption after normal block. Gotta love those. Now remember, this is either an obstacle or an opportunity. Not too many people can figure this stuff out, so I'm definitely going to look at this as an opportunity because this makes me some money. Oh wow, I feel really stupid. Sigh. Does anyone see what the error is? Now, if we were in the classroom, I would offer a shiny nickel or dime to whoever could spot the error. Here it is, right here. It has to do with the order of operations. I multiply by the size, and then I add 1 to that, so I'm adding 1 byte, not the size of 1 integer. So I need to add 1 to my size first and then multiply. Wow. So basically I think we should make a new variable for that. So int new size equals 0. So that's less confusing. And that is equal to the old size plus 1. And then we use that variable in here to help make it easier to read. And I haven't tested this yet, but I'm pretty much sure that that is my problem. Size 4, 2, 4, 6, 8. Yeah. That was a fun one, wasn't it? Now, how long would that have taken you to figure out? Probably hours, maybe days. That is why it is so important to divide and conquer, to do one thing at a time. See, this line is really complex and long. I don't like that I have to do an explicit cast and do a size of in there. We could probably help eliminate that, but we could make the variable new size and bytes, something like that. But do one thing at a time. Make your procedures 1 page or less so you can easily see all the code. Name things well, proper case, prefix, comments. Because on a large project it is so easy to get lost in the details, and little teeny bugs like that can be so absolutely maddening and frustrating. And so that is how we call add value to end. Let me make sure I'm printing it out. Yep, go ahead and print it. So yeah, there we go. That is how we add value to end. So the next 3, add value to front, insert at, or move at, I will leave up to you, and that is the end of the getting started video for homework number, what is this, 2000? Homework number 11, something like that.